Addition and subtraction of fractions. So whenever we are dealing with algebraic fractions and the addition and subtraction of those fractions, there are three main things we need to remember. Firstly, we need to remember to always factorize the denominator if that is what needs be. So when generally algebraic fractions, we will need to do some sort of a factorization. Factorization, just to recap, happens in four ways. We can either take out a highest common factor, we can talk about grouping, we can do a difference of two squares, or we can do trinomials. So those are the four ways in which, or the four main ways in which we factorize. Highest common factor generally happens if there's two terms. Grouping happens if there's more than three terms. Difference of two squares is a special type of factorization where we have two perfect squares that are being subtracted. And then trinomials, which are three terms that factorize into two brackets. Okay, so let's have a look at an example. So here is an example where we have 1 over a plus b minus 2a over a plus b, a minus b. So that's already in factorized form, which is great, so we don't have to do any factorization. So this one should be relatively simple. First thing we do, we need to find an LCD, and in this case, well, here's an a plus b, here's an a plus b. So what I need to make a common denominator is just this a minus b over here. So my LCD is a plus b, a minus b. Okay, super. Now that we know that, we can a plus b, a minus b, all over the same numerator. So now, to get our fraction, we need to say, okay, well, here was an a plus b, so what's missing is that, a minus b. So I need to multiply my numerator by what is missing. So 1 times anything is going to be itself, so I'm going to be left with a minus b in a brackets, just so it looks neater. Then we have the 2a, and do we need to multiply by anything? No, because this is the common denominator, so nothing needs to change. So if we want to simplify things, we can simply get a minus b minus 2a all over a plus b, a minus b. And over here I have an a and two a's, so that will leave me with 1a here, take 2 away, leaves me with a minus b over a plus b, a minus b. Okay, fantastic. So now, if we have a look, this could possibly be the end of our answer. But I'm going to tell you it's not. What we need to see is this minus a minus b could be a common, we could have a common bracket here. The only thing that's a plus b and that's minus a minus b. So if I were to take out a common minus, I would be left with minus a, so I divide by minus here. So divide by minus gives me a, divide by minus will give me plus b all over a plus b, a minus b. Let's just clean it up a little bit. So now we can see, wait a minute, here's an a plus b, here's an a plus b. There's only multiplication in my numerator and denominator, which means that I can cancel that a plus b with that a plus b, leaving me with an answer of just, let's create a new, and have a look. I have minus a plus b over a plus b, a minus b, and we said that this a minus b, or a plus b, can cancel with that a plus b, leaving us with a minus 1, because we need to leave a placeholder, over whatever's left over here. And that is your final answer. Here's another example where we have 2 over x squared minus x plus 5 over x cubed minus x squared. So before we look for a lowest common denominator, we need to factorize our denominators. So in here we can see here's an x squared and here's an x, so there's a common x to both. So we'll leave the 2 on the top, take out x as our common factor, leaving us with x minus 1. Plus, let's have a look at second fraction. Here I have 3 x's and here I have 2, so what is common is the 2 of them. And I'm left with x minus 1 and 5 as a numerator. So now I can look and say, okay, well, here I have an x and an x minus 1, and here I have an x squared and an x minus 1. So x minus 1s are common. Here's x squared. So the only thing that I need really to make them common is another x over here, so that's x squared. So my LCD becomes x squared into x minus 1. So I write that x squared into x minus 1, and there's my division line. So what did I need over here to make it common? Well, I just needed a little x. Plus, do I need anything in my second fraction? No, because that's already my LCD. So all I'm going to have here is a 5. And that is our final answer. 2x plus 5 over x squared minus, or into x minus 1. And we leave it in this form. We can't factorize that. There's no common factors. So we leave it in that form with the denominator in factorized form. Here's another example where it's just an extension of the previous example, where we take our common denominator. All I've done is I've changed our numerators. And what we can see here from our numerators is that here's a common 2 and a common x squared. So if I take them both out, 2x squared, leave me with, well, 2 divided by 2, 2 divided by that 2 gives me 1, and 3x's, take away 2, leaves me with 1x, minus, again 2 divided by 2 leaves me with 1. I have 2x's here, I take away 2, so x squared divided by x squared leaves me with 1. So I need to put that placeholder over my x squared x minus 1. So now we can see that through factorization, well, we've created a common bracket here, x minus 1, and an x squared and an x squared. So what we can do, because these are factors, there's only one term on the top, one term on the bottom. We can actually cancel that with that and that with that, and our final answer would just be equal to 2. And that is how we do algebraic fractions, addition and subtraction of those fractions. So just to recap and go back to slide 1, where the main thing we need to do So just to recap, we need to remember 3 main rules when we're adding and subtracting fractions. Firstly, we need to factorize or fully factorize the denominator using one of these four methods. Then we need to find an LCD so that we can turn multiple fractions into a single fraction over a single denominator, and then we simplify the numerator as far as possible. Thank you for watching.